Okay, we're going to do another surface area and volume, but this time we're going to do it on a cylinder. And you can see here the diameter of the pool Mr. Sato purchased is 8 feet. So that's the diameter. D. We use lowercase d for diameter. D equals 8. And this here looks like it's the height. The height of the pool is 20 inches. Find the measure to the nearest tenth. So, surface area of the pool. If I scroll back up here, or if you are on page 69, we're going to be using these two formulas. And this area right here is just the area of the base. All right. The other one is just, oh, sorry, no, I had that wrong. That is the area of the base. And 2 pi RH is the perimeter times the height. Perimeter times the height. So you can see it's pretty similar to the formula, but because it's a cylinder and you have to use pi's and stuff in it, we write it out a little bit more explicitly. So surface area is 2 pi times the radius times the height plus 2 times pi r squared. Well, we know what the height is. The radius is just half the diameter, which equals 4 feet. And now we've got all the pieces we need. 2 pi times 4 times the, oh, wait a second. This is 4 feet. I should not be multiplying feet by inches. So let's convert, let's convert the inches into feet. So if there's 20 inches, and we know that 1 foot equals 12 inches, then we can figure out what it is. That is 20 divided by 12, or 1 8/12, which is the same as 1 2/3, or 1.67 feet. All right, now we both have our units in feet. And let's go there. So 4 feet times the height of 1.67, that's just approximated, right? Plus 2 times pi times the radius squared. So I've got 2 times 4 times 1.67 is 13.36 pi plus 32 times pi. I'm doing some of the calculations in my head. You're in geometry. You should be able to do 4 squared times 2 in your head, or maybe if you need scratch paper, that's fine. But I'm not going to always write out every single step explicitly. It will just take forever to do all of our work. And now we're just going to add them together. One thing, they are like terms because they both have this variable, or this number pi on both of them. So I could add them together, or I could find them separately. 13.6 times 3.14 is 41.9504 plus 32 times 3.14, 100.48. And we add those ones up, 9504. And we get 142.4304. And in my work, it says round to the nearest tenth. So I'm going to round out the nearest tenth. Look at the 100th spot. It's a 3, so I keep the 4 the same. 142.4 feet squared. All right. Next up, the volume of the water needed to fill the pool to 16 inches. Now they give you the 16 inches here because that changes the height. So we're going to have to change the height again. 16 inches times 1 foot over 12 inches. And that would be 1 with 4 left over for 12, or 1 1/3, which is approximately 1.33. Since I'm rounding to the nearest tenth on these problems, my approximations for the fractions, I'm taking them to the hundredth. One extra unit on it while I'm working, so then when I get to the final answer, then I have something to round. All right. So the volume of a cylinder is the area of the base, or pi r squared, times 2, plus the circumference, 2 pi r. Oh, sorry, no. I'm doing surface here again. So the area of the base, pi r squared, because that's a circular base, multiplied by the height. So pi times the radius 4 squared times 1.33. 4 squared is 16 times 1.33 is 21.28 times pi, so times 3.14, and we get ourselves approximately 66.8192. Round to the nearest tenth, so I looked at the hundredth, it's a 1, so it stays the same, and I get myself 66.8 feet cubed for the volume.